Hi everyone. Go ahead and open your books back up to page 81. Or I guess you could turn to page 82. We are going to look at this roller coaster graph again, and we're going to start answering the questions in the book. It might help you to have your vocab out in front of you. So what I would like you to do is use the roller coaster graph on the previous page, which is page 81, to answer questions 1 through 5. And if you wrote down what I wrote down here on this slide in your book, it's going to help you answer those questions. Make sure that you're fully answering questions 1, 3, and 5. Go ahead. So question 1 says, what is the y-intercept of the function shown in the graph? Okay, so remember, our y-intercept is where our graph touches or crosses your y-axis, and it's always when x equals 0. So that occurs at 10. It's circled in green. But then it says, what does it represent? What does it represent? So it represents the height of the roller coaster. I'm going to abbreviate. When the ride begins. At time 0. So when we get on the roller coaster, we're 10 feet above the ground. So we're starting at a height of 10 feet. Identify a relative maximum. And remember, this cannot be an endpoint. There's actually 2 of them. Where's there a hill in our graph? One is at 90 or 110. So if you had one of them, you're good. You would get the question right. Question 3. Identify the absolute maximum of the function. Remember, that's the highest point no matter what, no matter where it occurs. So the tallest point of our roller coaster, the biggest height is 110. Remember, this can be an endpoint if necessary. And it says interpret its meaning. So if we go back up, remember our maximums and minimums, we're looking at our y-axis the whole time, up and down, low to high, for our maximums and minimums. So what that means is if we're interpreting, we should probably read the label along our y-axis. So for question 3, this is the greatest or the highest height reached by the roller coaster. Number 4, identify a relative minimum. Again, remember, relative cannot be an endpoint, and it has to occur within our graph or throughout our graph, and it's a valley or a low point. So that occurs at 30. Number 5 says to identify the absolute minimum of the function. What's the lowest point no matter where it occurs? It can be an endpoint. It could be in the middle. The lowest is 10. Interpret the meaning. Again, we're going to read the label on our y-axis. And this is the smallest height, or the lowest height, or the shortest height reached by a roller coaster. So relative minimums and maximums, we look for hills and valleys throughout our graph. In the middle, it cannot be at the endpoint. Absolute minimums and maximums, we're looking for the lowest point and the highest point no matter where they occur. If it's an endpoint, it works. If it's in the middle of the graph, it works. Okay? Page 83, question 6. Ooh, we're looking at a new roller coaster now, and it's called Cougar Mountain. And it immediately starts climbing the track in a linear fashion. Linear means straight line. We are going to look at question 6 first, which is identify the domain and the range. Right, so domain. Domain. Remember, domain is our input. Our x values are independent variable. So we are going to look at our x-axis, okay, and we look from low to high, from left to right, small to big. So we're going to start over here, furthest to the left. See how my graph starts here? And it goes all the way, it ends right here. So what's the starting number here? The lowest number for this left is 0. Remember, domain and range, we use fancy brackets. My highest point, where does it end? Right here, at 200. In domain, we use x, so we're going to put that in the middle. And x is greater than or equal to 0, and x is less than or equal to 200. So x is in between. Don't worry, we're going to practice a whole lot more with domain and range. So fancy bracket, range is our y values. Here's my y-axis. So I'm going to look vertically. My graph starts down here at 0, and it goes all the way up. Ooh, what's this number here? Where does my graph end? Right here. Well, 0, and then I jump, and then I go to 50. So what's halfway between 0 and 50? 25. So we need 150 plus 25, so that gives us 175. So 0 is where my graph starts. 175 is where my graph ends. Now, your y-axis goes all the way up to 250, but my line does not. Okay, notice my line stops right here, and that number is at 175. So y is greater than or equal to 0, and y is less than or equal to 175. All right, I would like you to try to pause this video and answer questions 7, 8, and 9. Y-intercept and minimums and maximums. You can do it. So number 7 says identify the y-intercept. Okay, remember that's where your line touches or crosses your y-axis. So here's my y-axis. It always occurs when x equals 0. So 0, comma, whatever that y value is. So it's right here. 0, 0. Your y-intercept intersects the y-axis. Number 8 says identify the absolute minimums and maximum. So remember, these can occur at your endpoints. Right? So where's your lowest y value here? Again, we're going to look up and down vertically. My lowest y value. It's the minimum. It occurs right here at 0. Right? So my minimum would be 0. And my maximum would be not 250 because my line doesn't go all the way up there, but it stops right here. And what's that number right here? It was 175. Now, I want us to notice something before we move on to question 9. If I look at question 8, my absolute min and my absolute max, those match something else right now that's on the board. Look at question 6. Your range, remember, is your y values. So your lowest y value at the bottom of your graph, your highest y value at the top of your graph. Well, your absolute max and absolute min are your lowest y value and your highest y value. So this is one way to check your answers or to see if you made a mistake somewhere. So look at my absolute minimum was 0. This is 0. My range value starts at 0. My absolute maximum, my highest y value was 175. My highest y value for my range is 175. So if you want to, you can make a note. Your range values, your y's, have to match your absolute maximum and your absolute minimum. Question 9 says, does the function have any relative maximums or any relative minimums? Remember, relative max or mins cannot be endpoints. So, do you see any hills and valleys here? No. There is no relative minimums or maximums. My graph is a straight line. And my absolute max and my absolute min occur at the endpoints, so they cannot be relative max and a relative min. This is a straight line. Our graph doesn't change direction. We don't have hills and valleys here. So question 10 is kind of getting at that. I'm just going to briefly talk about this. How are the extrema? Extrema refers to all maximums and minimums, relatives and absolutes. How are they different on this linear graph up above question 9 with the Cougar Mountain compared to this curvy, hilly graph of the Thunderball roller coaster? Well, if you're looking at the linear graph up above on the top of this page, your extrema, your maximums and minimums occur at the endpoints because it's a straight line, it's linear. On your nonlinear graph, and I put the picture here for you under question 10, this roller coaster goes up and down. It has a lot of different heights, some hills and some valleys. We're changing directions here. It's curvy. So extrema occur in the middle of your graph as well as on the end of your graph. So straight lines, we had no relative minimums and maximums. Curvy lines, we had all 4. Okay? Question 11. The graph below shows 5 points that make up the function. I want you to write down the answer to this question. Is this function continuous? And then make sure you're explaining. Is this graph continuous? No. Why not? The points are not connected. This function is discrete because it's disconnected. There's individual points. A function has 3 relative maximums, 3 hills, 3 high points in the graph. Remember, these occur in the middle. Okay. So one's at -2, one's at 10.3, and one's at 28. One of these high points, one of these hills, one of these relative maximums is also the absolute maximum, the highest y value, the highest number, no matter where it occurs. So which one is it? The answer here would be 28, right? That's the biggest. That's the maximum. Okay? All right, let's look at Tom. Tom is hiking a circle trail known as the Juniper Loop. The graph shows his distance d. So d, this is like our y-axis. It's labeled d because it's the distance from start. From the starting point after t minutes. So this is like our x-axis, and it stands for time in minutes. Okay, so let's look at the domain and range here. First of all, this is 0, then I have a line, then I have 30. What's halfway between 0 and 30? 15. Half of 30 is 15. So these are going up by 15s. Okay, so what's 150 plus 15? It's 165. So this tick mark right here at the end is 165. Perfect. All right, question 15 says to identify the domain and range. So I'm going to help you with that. Domain, fancy brackets, always. Domain is our x, our input, our independent variable. Or in this case, sorry, I should be using a t technically for time. So let's look horizontally from left to right. So my graph starts right here at 0, and I'm graphed all the way to 165. So my time is greater than or equal to 0 minutes and less than or equal to 165. Okay? Then my range values is on our y-axis, which is labeled a d for distance, and we're going to look vertically up and down. So my graph starts right here. That's where my line starts, and it's at 0. And I'm going all the way up to 7 is where we stop. So my distance is greater than or equal to 0 kilometers and less than or equal to 7. Okay, I think this is where we're going to stop today, and then we'll pick up tomorrow.